District Latur, is organized World Record Series 2. Today is the 111th day of the series, and the keynote speaker is with us for today's session, Dr. Ashwini K. Patil, Madam. So first of all, I welcome to you, Madam, for the dais.
Yes, thank you, sir.
I welcome to the Chief Organizer of the World Record Series 2, Honorable Principal M. Ambedkar, sir. Then I welcome all my dear colleagues from my college, IPAC Coordinator Sanjay Kale, sir, Dr. Karal, sir, Dr. Sudhir Garad, sir, Dr. K.N. Kadam, sir, Vocational Supervisor Praveen Udge, sir. And lastly, I welcome all dear participants, students, researchers, and all those dear participants. For the presentation, for the session is wind turbines. Now this topic is going to present Dr. Ashwini K. Patil, Madam. In short, I introduce the today's keynote speaker, Dr. Ashwini K. Patil, Madam. She is an assistant professor from Karmaveer Advocate Baburao, Ganpatrao Thakare College of Engineering, Nashik. So with this short introduction, now I request the keynote speaker, Dr. Patil, Madam. Please start your presentation on today's topic, advanced technology in renewable energy wind turbines. Please welcome, Madam. Please welcome.
Thank you, sir.
Yes.
Thank you, sir. So good evening to all. As sir has already introduced, myself Ashwini Patil, and I'm assistant professor in Liberty College of Engineering, Nashik. And we are going to talk about advanced technology in renewable energy, like wind turbines, and few more today. Solar also. Okay. Yes. Yes, sir. Yes, sir. Just a minute. Yeah. So, am I visible now, sir?
Yes, Madam.
Yeah. Thank you so much. Yeah. So basically, the motivation behind discussing this topic, that advanced technology in renewable energy, is today, in today's era, we are in need of power, tremendous power, and 60 to 70% of the power which is generated in our India, it is from thermal power plant, and which is harmful definitely for our next generation, and also the fossil fuels like coal, oil, or gas, which are used as fuels in these thermal power plants, are making tremendous pollution, which is again harmful for the health of our next generation. So, we'll start with thanks to Dr. Betkar sir and all the listeners. So, why renewable energy resources? So, basically, the global challenges are that climate change mitigation, energy security and independence, energy, air pollution reduction, sustainable development, resource conservation, technological innovation, and economic opportunities, and environment conservation. So basically, if we'll see that in few countries like Norway or New Zealand or Brazil, they are using renewable energy at tremendous amount. Even in Norway, if you'll see, there are 99% of the energy which is generated in Norway country, it is by hydropower plant. And so why we have not at that position in today's era, that also we'll discuss. And another very important thing is that everybody of us, we should always remember that saving energy is generating energy. So in everybody's home, at workplace, at in industries, and various places we are day to day using this power. And sometimes we are not bothering that the power is getting waste. So that if will curtail the use of power, or will use the power at optimum, so that saving of power is generating the power. That is first and very important principle. Then another thing is, as I told, that why renewable and why not thermal. So in a thermal power plant, mostly the coal fired plants are there, oil and gaseous plants are there. And even in these even in some countries like Japan, the nuclear power plants are there, where the atomic energy is used for the generation of power. All these resources are, first thing, these are all reducible. Time by time, day by day, these are getting reduced. And so some time will be in crisis of it, rather we are in crisis of it. And secondly, as I told, yeah. uh, is it? Yeah, yeah, yeah. Thank you. So basically, first of all, that we are in crisis, will be in crisis of these different fossil fuels. And secondly, the pollution, or that global warming, which is a very we are now we see that all the seasons in India also, these are getting changed. Even the rainy season, which must start at on 7th of June, it has not yet started. So this is all due to the global warming. And more or less we have a role in it. And this thermal power plant has a role in it, because coal, when we generate, so we require, we need to cut the plants. And we use the coal and various fossil fuels in that. So these are the some major renewable energy resources in India: solar power, wind power, hydropower, biomass energy, geothermal energy, tidal energy. Out of which 60 to 70 per 60 to 65% about we use thermal power plant. And about 25% of the energy generation, it is by solar power plant. And 10% about it is wind power, and very less, about 2%, it is hydropower. And other resources we use are very very less. So basically in India, the all these renewable energy resources or power generation, it is dependent upon the weather or the environment, so the suitability of the environment. So hydropower is if hilly area is there and good rain is there, then only we can go for this hydropower plant. So rarely we have in Maharashtra these hydropower plants. But if we'll go to the Tamil Nadu, we'll see that in every village there are so many independent villages which are working on the hydropower. Then if we'll see the solar and wind power, so we'll be discussing it in detail in the next slides. Is it visible, sir? Next slide.
No, madam. The same is there.
Same in every. Okay. Now is it visible?
Yes, it's changed now.
Yeah, yeah. So the solar energy. Now, basically, in our India, we have tremendous or abundant sunlight which is available. So some of the plus points and minus points of this solar energy are: solar energy is again free of cost. The all the renewable resources which are free of cost. So, but the large scale power plants or power plant projects which are rarely available in past, but nowadays due to the initiative of government, the large scale solar power plants also has been implemented nowadays. And also basically in our home also, normally we use solar geysers for heating the water. That is the very preliminary resource. But there are again two types of resources which we can use, that is off grid and on grid. So off grid are like we are using the solar power, solar panels, and getting the output. And on grid we can generate, and we can sell it to the government. Like that metering will be there and will save the light bill. So basically there are good enough facilities or subsidies and incentives are given by the government for this particular power generation, like capital subsidy. If you have to, in the initial cost, which if it is very high, so for that capital subsidy is given by the government. Then generation based incentives, then interest subsidy on loans which are taken for the solar projects. Then goods and service tax exemptions, these are also given. Then custom duty exemptions. So these are the facilities we can use, these facilities for the generation of this for the for using this solar power. These are the now most of us we are knowing that how the solar power is generated. Normally solar power, how it is generated, the solar panels are used, then the energy is converted through inverters into AC form. Batteries are used for storing this energy, and further if it is off grid, then we can directly use it for loads like fans, lights. And if it is on grid, we can sell it to government, or our bill will be redeemed from it. The very now in nowadays, this photovoltaic solar system, the technology which is, or the researches are going on this agri photovoltaic solar systems. So in this we can see in the picture that how the advanced control is there, like in the farms. In these farms we can see the solar panels are mounted, and in between the two solar panels we can see the crops are the crop yields are taken in the controlled environment, so that we can get we can get dual income from the land use of, because the land is a source which cannot be generated or it cannot be reduced. So it is day by day we have to use it more optimum way. So basically in farms we can see how the solar panels which can be mounted, and in between these two solar panels the crops are taken the yield from the crops. The researches are going on that which types of crops can be yield in this in between in this control condition by using with using the solar panels also. And here the benefit is that farmers can sell this on grid. We can use the on grid solar system, so that we can sell, we can generate the power also, and we can sell it to the government. And another thing, the crops which are suitable in this environment, so they can take, the farmers can take the yield. Now there are good enough facilities even for such types of project which are recently growing in our India. And one more facility which is given, like the farmer can give their land to the government on lease. And even like suppose the lease is of 30 years, so after those 30 years the farmers there, the farm will not be completely taken by the government, only it will be, they will give the rent to the farmer. And both the things, like this energy will also be generated, and this farming also be farming also will be done. So this is the agri photovoltaic solar system. And as I told, already the plants have also been installed, and recently the researches are going on in this field. So this is what is the agri photovoltaic. Basic advantages are dual use of land to solve the food security and energy security concerns, then security to farmers income, rainwater harvesting for irrigation and panel cleaning purposes. So there even the rainwater harvesting can be done, which can be used for irrigation purpose also, and for this panel cleaning purpose also. Crops in between PV array check the erosion of the soil and reduce the dust load on PV module. Then even the jobs or employment can be created. So this is how it makes the this sustainable. So increase the yield of agricultural production and improvement in the soil properties. Now the main topic today's main topic is wind energy system, which is the another, like thermal power plant. Highest energy is generated in our India, then solar, and then wind. So how we can use the wind at more more efficient way that we'll discuss today. So first of all, harnessing the power of wind is nothing but, we all of us must have seen the wind turbines. Many of us, when we travel at our Nashik, at Nagar, or at Dule, at Sakri, there are so many farms of wind turbines. Means farming of wind turbines is done at particular distance, or keeping the particular distance in between these the two wind turbines. The farming of wind turbine is done, means the wind turbines are installed. First of all, let me tell you that why this wind turbine has not, only why 10% of the energy is generated due to the wind turbines. The basic difference between thermal power plant and these wind turbine or solar plant are that when the plant is installed, thermal power plant is installed, it is of very large capacity, like about 1000 megawatt, about 1000 approximately. So 1000 megawatt is generated in 1 hour in thermal power plant. But when we use these wind turbines, one wind turbine in India, it is about 2 megawatt. Nowadays 10 megawatt capacity wind turbines are also being installed, but very rarely these are installed. The wind turbines which we see here, like at Nagar place or at Sakri places, so these are of very less capacity, more even less than 1 megawatt, like zero point 0.8 or point below that. And that is the reason that even though the farms of these wind turbines are there, its capacity is very less. Thermal power plant, which where these are 1000 megawatt, and where these farms of wind turbine, overall its capacity is about 20 megawatt or about it. So this is the thing which is lacking here. So why wind turbines cannot be of very large capacity, and why advanced technology we need in this wind energy system, that we'll see further. So benefits, all of you, all of us are knowing that the air is, wind is free of cost, it is available, and it is a clean source of energy. Very less drawbacks are there, but drawbacks are also there, like wind energy systems, where these systems are installed, it make very much noise. So the residential area near these wind farms, so that people may get even that somehow they may get diseases of hearing. Another thing is sometimes the birds also they get affected by these wind turbines, due to these wind turbines blades, which are very huge. And if they will get obstructed due to the bird will get obstructed due to the blade, they will die, it will die at the place, or it will get wombed. So then the community wind power means at our home, at our industry, we can use the small capacity wind turbine or hybrid, that is wind plus solar, at our home also. But we find very rarely this type of wind turbine also. Government is taking or giving the subsidies similar to the solar also. So we should also move forward towards the wind turbine. Then embracing a sustainable future, as the as again the employment will also be generated. The fuel is not required here, the wind is free of cost, it is available. So obviously the sustainable future is there for this wind turbine. Why we have I have chosen this topic today. So the motivation behind this was like demand of power. First of all of us must be aware about the power that which we are using at home. It should be optimum at workplace, everywhere. So that's what I thought, that awareness should be created among the people. Another is drawback of thermal power plant, already we have discussed. Then the why this wind turbines has not yet developed with more amount, that is lack of control on wind energy failures and condition, or monitoring system or fault tolerant control system. These are the advanced control systems which are needed in India also. Out of India these are available, and even in India also these are available, but in very less amount, like in Siemens or GE, that is General Electric company. They are doing good enough research in this era. That's what I have read. Then statistics of cumulative capacity of Indian energy. Globally, this is the statistics, and in India, this is the day by day it is increasing, but the amount which should be increased it not is not that enough, which should be increased. Basically, how wind power is generated, that we'll see first, and what advanced technology is being used or is will be researched further in India, that we'll see further. So this is the basic wind turbine, and it is having good enough automation, which is, if you will visit the wind turbines here of that Suzlon's wind turbines, so you will find that very less automation is there. Oh, I'm so sorry, sir. Uh, is it visible now? Yeah. That's what I am discussing now. So, lot of slides may not be visible. I'll take care of it now further, sir. Thank you. So, in this wind turbine, we can see this is a tower. More heighted the tower is, more stable and more speed of wind is. Another thing is, here the nacelle is there, which is mounted on this tower. And at one end of the nacelle, there is a rotor hub where the blades are connected to this rotor hub. At another side of the nacelle, there is an anemometer to measure the wind, and there is a wind vane to show the wind direction. Then inside this nacelle, there are brakes, gearbox box to exceed the speed of the rotor, and then generator. This is what is the generator, which generates the electricity and give it to the grid. So the basically the mechanism here in the good automated wind energy system is, here there is a yaw mechanism which help to this rotor hub to keep its face towards wind or perpendicular to the direction of the wind. So as wind when show the direction accordingly, this yaw mechanism will move this shaft towards wind direction. So this wind will be converted into the mechanical energy through these blades, and through this shaft the mechanical energy or rotational energy will be given through this gearbox to the generator, and generator generates the electricity, which is further given through grids to the substation or further at collective place. So gearbox is for increasing the speed of the rotations. So mainly in India, the mean speed of rotation, speed of wind is average. It is not very high or it is not very less. But in India, the coastal area or seashore is good enough available where the wind speed is good enough more, which can be utilized to increase the installation of wind turbines. So here basically the automation is, as I told, the basic wind turbines which we have, they are not having too good enough automation. If the wind will be low, the wind turbines will stop. If wind will be high, again the wind turbines will be stopped. So they are not very effectively utilized for the generation of power. That is the reason that we cannot get good enough energy from the wind turbines. So here in this wind turbine, we can see here that these blades, every blade is divided into two parts. Even in our fan, we see that the blades are divided into two parts. So angle between these two parts, it is called as pitch angle. So that pitch angle is controlled to maintain the optimum speed of rotation of this wind turbine. This is the first control. Then another is a torque control, and third is a this yaw control, its direction. Here there is a motor which control the direction of this nacelle or shaft towards the wind direction. So these are the major three controls, but further there are tremendous amount of automation which is needed. That is to avoid the failures of the mechanism, the lubrication, proper lubrication system, then temperature of that lubrication system, viscosity to maintain the temperature and even viscosity of the lubrication system, and a few more things which are there for the automation, that we'll see in the next slide. So this is how the wind, which will be converted, that kinetic energy of wind is converted into the rotational energy of the rotational energy through these blades, and further through the shaft this rotational energy is further converted into the electricity with the help of generator. The brakes are there to stop the wind turbine when the winds are very low. When the wind turbine generate the energy below economic level, or the wind is very high where the structural failure may happen in the wind turbine. So this is what is the working of the wind energy system. I'll go to the next slide. So here, basically, they in fully automated or full automation automated wind turbine, there are two regions: partial load region and full load region, where wind turbines work. So, what is partial load region? See, 3 meter per second. These are the approximate statistics. Below 3 meter per second wind speed, the wind turbine should be stopped because it generates the energy below economic level. Then in between 3 to 12.5, with full automation, the wind turbine will be run with optimum output. And above rated, that is 12.5 to 25 meter per second. So here the maximum output we get, but then we have to have the good enough automation to run the wind turbine at optimum speed, because if the speed of the rotor, if it will be increased above rated speed, the definitely it causes structural failure of the wind turbine. And the structural failure of the wind turbine, its loss is very high, very huge. So the losses of this the structural failure are many other losses, but this could be the one of the reason that wind turbine failure could happen. So in partial load region, the another controller is there, and in full load region the different controller is there. So this is what is the control system which is used in wind turbine. Wind turbine is there. So speed controller is there, torque controller is there. These are the major controllers, and which are used in full load region. In partial load region, only speed controller is there, because torque is already less in partial load region. Now, basically, fault tolerant control. Uh, if we want to have the maximum yield from wind turbines, we need to install it offshore, because at offshore the environment conditions are like good enough wind speed is there, but then the weather conditions also are harsh sometimes. So how harsh? Wind speed could be from any direction, like storms could be there, lightning could be there, and these storms and this lightning can cause the complete failure of the system if the good automation or good structure is not designed. So in such cases, if the system get failed, tremendous economically it is not feasible. So if we have to increase the yield, and if we have to install these farms at offshore, as in India, good enough coastal area is available, and if we have to install it there, so these fault tolerant control systems must be used. This is the advanced control system. What is this advanced control system? So in previous slides we have seen the control system. This is what is just the control system, but fault tolerant control system is what? So in fault tolerant control system, basically if fault will occur, like if some part of the system, suppose there are tremendous amount of sensors which are used, so if some sensor will get fail, some of the part will get fail, so it will not abruptly fail, it will give some indication before getting failed. So those conditions should be monitored, and the before fault which will lead to failure of the system, that fault should be identified by the fault tolerant control system. So what is the main role of fault tolerant control system? The To identify the faults all the various types of faults, particularly in control system faults like sensor failure or actuator failure. Because if automation will get fail, definitely the system will get. If some mechanism if some small fault will be there in mechanical part, so it will not abruptly fail. In between the maintenance will happen. In that maintenance, that fault will be cured. But if automation will get failed, definitely the structural failure of the wind turbine will occur. So in that case, what fault tolerant control system does, the control system identify the fault with various methods. That methods we'll see in the next slides. So first of all, it will detect the fault. Then fault isolation. So basically, where this fault has occurred in some sensor or in control system or in actuator or in any other part of the system where this fault has occurred, that will be identified. And then that fault, by analyzing the severity of the fault, so that system will be isolated from the fault. So this is how the fault tolerant control systems are there. So this is the fault tolerant control system. The fault tolerant control system, you can see here the plant is there. So wind turbine plant could be this. Then the controller which is working for this wind turbine, normal controller which is controlling the speed, which is controlling the torque of the wind turbine, which is controlling the yaw mechanism. So this normal controller is there. So in this case, the diagnosis, this separate controller, this is a separate part of the controller where the diagnosis, separate different algorithms are written, with which by using some different sensors, the diagnosis is done. Diagnosis is in the sense that what type of fault could be there. When we go to the doctor, what doctor does, doctor asks us that what is happening with us, and will tell different things, and doctor will diagnose our disease. In similar way, what this control system does, there are different sensors in the plant, and from the output of those sensor, this fault tolerant control system analyzes that what type of fault is there. That is what is the diagnosis. Then this diagnosis is given to the controller redesign. So if some sensor has got failed, so either instead of one sensor, two sensors are installed, and another sensor, if one sensor will be failed, automatically controller will take the output of another sensor, that is the redundant sensor. And again, one more advanced method is like the controller estimates the parameter of that sensor. If that sensor get failed from the another different conditions, the control system estimate that particular parameter. For example, if some speed sensor or encoder is there which is reading the speed of the wind turbine, and if this sensor will get failed, so what this control system will do, from these different sensors it will analyze mathematically, or it will estimate mathematically the speed of the rotor, and that speed of the rotor will be given to this controller. This controller, instead of using this sensor's output, it will use this control this fault tolerant controller's output, and the controller will work smoothly. So this is how the fault tolerant control system, for control normal control system, it will work for sensor, for actuator, and even for controller. So this is what is the block diagram of fault tolerant control system, which can be used, or which must be used for the fault, for the wind turbines, and which is already has been used in few wind turbines. So in normal case, this is the wind turbine, this is the controller. This controller controls the parameter, and this complete is the fault tolerant control. In case of failure of some of the parameters here, this fault tolerant control will take charge, and your system will work well as it was. So there are two types of fault tolerant control system. One is passive fault tolerant control system, Another is active fault tolerant control system. In passive fault tolerant control system, the controller itself has got such design that it will work in normal condition and in different way with faulty conditions. And active fault tolerant control system, there is a different separate controller which is used. If normal controller system will fail, so it will discard that control, and another fault tolerant control system, it will take a charge and will work well. Basically, these are the faults in wind energy systems. Few faults are incipient faults. Incipient faults means day by day the it will reach to the failure, but it will take good enough time. So will get good enough time for doing its maintenance. And abrupt fault are abruptly something will get failed, and in that case, our control system should take care of that particular fault. So rotor hub and blade faults, same thing, in which blade where pitch fault could be there, or even mechanical fault could be there. In pitch sensing is a pitch system, there are different such faults could be there. So all these faults should be taken care of the fault tolerant control system. Then drivetrain fault, mostly all the drivetrain faults are mechanical fault. Only the speed sensor fault, it is a control system fault. Then power system fault, in generator there could be different types of faults. Then power sensor fault, torque sensor faults. These are the various faults. In wind energy system overall, the yaw mechanism fault, where the system mechanical fault also could be there and control system fault could be there. And even tower, this mechanical faults could be there. So basically, the fault tolerant control system, which should work more efficiently on these control system faults, where the sensors, majorly pitch sensor, generator and rotor speed sensor, power sensor, torque sensor, and in actuators, converter faults and pitch actuator fault. So control system works on these various fault tolerant control system works on these various types of faults. Even though the fault will occur, system will take a charge and will work well. So there are various fault tolerant control methods: signal based method, model based method, and expert system or knowledge based method. So what are these different methods that we'll discuss in very short. The signal based method is putting all the various sensors in all the various parts. Like if blade is there, suppose some crack is there on the blade, so it will vibrate. So that vibration sensor is mounted on the blade, which will give signal that some fault has occurred in the blade. So before reaching that fault to the failure, that will be taken care, that fault will be removed, either the blade will be removed or the crack will be taken care. So this is what is a signal based fault. Model based fault is a mathematical, completely model based means the mathematical model will be there from the whole system. Mathematical equations are designed and which estimate the sensor's output. Like if speed sensor has got failed, so that mathematical model will estimate the speed, and that estimated speed will be used by the control system. And third method is expert system. We all are knowing the expert system like fuzzy fuzzy systems or artificial intelligence, and these are taking over the charge nowadays very speedily. Then these are the different methods. In signal based method, these are the various parameters: strain, temperature, lightning detection. These are by using different sensors, these parameters are analyzed and fault is detected and the fault is taken care of. In model based method, these are different models, like to evaluate the mathematical model: system identification and parameter estimation, observer designing, LPV, that is linear parameter varying design. Then model reference adaptive method, model predictive control, H infinity control, sliding mode observers. These are very very advanced control systems, but in our India very rarely very advanced systems are used. But now this has been researched well by the companies and getting used. Like I told, that companies like GE, or that is General Electric, or even Siemens, they are taking care of these systems. Fuzzy based and neuro fuzzy based and data driven. These are the expert system. These are the intelligent. They are acting like a brain and working on it. So in this way, there are different. Basically, the lightning is one of the major reason that the structural failure may occur, and storms, which is another reason where the structural failure may occur. So if these faults are taken care, or these failures are taken care while designing the wind turbine itself. So if well research will be done in this, then we can have the wind turbines more than 10 megawatt capacity. That means one wind turbine above 10 megawatt system. So the farms will be like 100 megawatt systems farm, or 500 megawatt systems farm. And in this way, the renewable energy which will be more effectively utilized in our India. So with this, I'm ending this session. Thank you very much. If you have any doubt, please ask.
Thank you very much, madam, for the wonderful presentation. Now I request dear participants, please, if you have any query or doubt, please come ahead, discuss with madam. Please, participants.
Hello, good evening, ma'am. Thank you
Good
for the
evening.
excellent presentation. I would
You.
have one note, ma'am. Like these are already installed, or depending upon our requirement, they can be installed in the particular PVs or the wind this one.
Yeah, thank you, ma'am, for your keen interest. Actually, whatever the installed wind turbines are, those are having very basic automation. Even we had visited few of it. So very basic PLCs are used for automation over there. So if we have to increase the efficiency, we need to design the wind turbines in such a way that higher capacity wind turbines with good control system and with good fault tolerant control systems. But in residential area, we cannot go for tremendous automation because it is not affordable. But at moderate amount, we can have it in these areas. But offshore wind turbines, we can have the good enough automation so that we can increase the capacity. So we need to install new with advanced technology. Have you got the answer, ma'am?
Yes, ma'am. Yes, ma'am. I got.
Thank
Means
you so
basic,
much.
it will be a plane. Depending upon our requirement, the cost will increase.
Yeah. Yes, ma'am.
Okay, ma'am. Thank you.
Madam, good evening.
Yeah. Good evening, sir.
Madam,
Should I share? Yeah.
having said that this advanced technologies in renewable source of energy, why
Yeah.
the India is really hue and cry about power shortages. We have such a good source of you explained wind energy, other energies. Are we not tapping such resources to make available the energy or electricity to all the remote areas of India? Still, in the most of the areas are not connected with this.
Uh, Sir, actually, that's what that we were more rely on or dependent on the thermal power plant till date. As I told, that 65% of the energy, because more energy is generated through this thermal power plant. But if such efficiency will be increased and more advanced technology will be used in India, then only we can go and we can more rely on the these renewable energy sources like solar also, as agrivoltaic, which is again very effective resource. And another resource is like wind also. If offshore wind turbines will install with very high capacity and very good advanced technology with full automation, then only we can go for high capacity and will more rely on it. But till date, actually till date, we don't have that much advanced technology. Nowadays the researches are going on it.
Well, then a lot of developments are taking place in the West world and
Yeah.
other areas, and they are using more of solar energy and wind energy. And I think India having 75 years of completion, still we are not, we are, as you are saying, advanced technology has not yet tapped. It should have been tried. I mean, the ITs are doing good job. I was told because I'm not from
Yes,
this
yes,
electrical,
yes.
but still, why this should be 75 years of independence. Still, we are short of energy. We are borrowing from here and there. That should be really panic condition for Indian economy.
Definitely, sir. Actually, that with technology, we must go with the renewable, and I think we are on the way because in 2024, that solar energy very good enough power will be generated by
Yes, ma'am.
2024. That's what we have heard. But again, we should use more and more resources like this wind and hydro also, so that this thermal power plant should get reduced.
Okay, thank you so much, ma'am. Thank you so much.
Yeah. Thank you. Uh,
Vinod Desle, sir. I think you would like to ask something. Please come.
yeah. Hmm. Yes, yes, yes. Yeah, yeah, I'll answer. Actually, 7 kilowatt, I don't know exactly, but about like a huge amount means zero point 0.8 megawatt. Before 2 3 years back, we had visited and we had asked this question to the company. So that time they told that 10 crores of cost, about zero point 0.8 to 1 megawatt, that much is required. But this small amount, like 7 kilowatt, I don't know actually exact amount.
Not
Have you
which
got
is
the answer?
depending upon the area also, no, ma'am, like depending upon the
Ah,
width and the size
that
also.
yeah, that survey is done. Wind turbine is never installed within a 1 year or 2 years of survey of wind. It is done before installing the wind turbine. Otherwise, at any area we cannot install these wind turbines. After doing this survey only, we can go for this. Yeah, domestic we may think about, but not this huge power. Or hybrid at small amount we can go for this, but for large amount, good enough survey is done.
So means weather condition is taken, ma'am, to care, like weather condition depending upon that they are installed in the particular location.
Yeah, yeah, yes.
Okay, ma'am. Thank you.
Yeah,
We have
thank you.
separate Ministry of Renewable Source of Energy. Ministry is created. What is the present status of renewable source of energy? Present status of the how much what amount of energy is being produced so to cater the needs of the people who are not having the access to the hydroelectricity. Even,
Yeah, I couldn't get the question. I
no,
understood,
no,
but
yeah,
huh.
in the sense that the replacement of hydroelectricity because water is not so much available in India as a scarce source, and that's what government of India is thinking of shifting to renewable source of energy. For the purpose, it has created a ministry in the Ministry for in a renewable source of energy. So, what is the
Right,
present
right.
so in this context? What is the area it is covering in India? Because most of the Odisha, Chhattisgarh, and this part of the Bihar, they don't have the hydroelectricity resources. I think those states must be covered with the this renewable source, the wind energy or with the what you call solar energy.
Yeah, yeah. I cannot exactly tell the status, but solar, good enough efforts are being taken on solar. And but even hydro, it is totally dependent upon the hilly area and that rainy the season, that how much rain is there. But then wind, I don't know, to maybe efforts may be taken by the ministry in for wind turbines also. Actually, wind farms are being installed up of good enough capacity even in Maharashtra also, about 10 megawatt, but the exact status, I don't know.
Thank you so much.
Yeah, thank you. Anybody else?
Thank you very much, Deepa Samat madam, Dr. Badiuddin sir. and Vilas Sonwani sir. You have asked the questions in interaction sessions. So thank you very much, and Madam, you have answered it very well. Now
Thank
I,
you from my side also.
yes, Madam.
Everybody.
Now I would like to request the chief organizer of the series, Honorable Principal M. Betkar sir, please come and have a concluding note for us, please, sir.
Thank you very much, sir, for giving me this opportunity.
Thank you for the concluding words, sir. Thank you very much. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur, organized a World Record Series 2. We all of you know that today is the 111th day of the series, and the keynote speaker were available for today's session, Dr. Ashwini K. Patil Madam. Talked upon the topic advanced technology in renewable energy, wind turbines. So this topic have presented very well. Ma'am have covered every aspects to the topics. While presentation at the very first, ma'am have said that given one beautiful message that saving energy is generating energy. So it is a very beautiful message to all of us, because if you save the energy, then definitely we generate more energy. And ma'am also highlighted upon the different points in her lectures, some of the major renewable energy sources in India, then agri photovoltaic system, how does it works, then wind energy system, its descriptions, wind energy system, its operations, control system in full load regions, and fault tolerant control system blocks. Now these are the points covered in her lecture. Actually, we were feeling that as we have visited the power stations, and madam have explaining it very nicely. So thank you very much, madam, for the wonderful presentation. Thanks a lot. I express sincere gratitude towards you. Then I thanks to Honorable Principal Sir, who is the chief organizer of the series. Then I thanks some of the colleagues from my college, IQAC coordinator Dr. Sanjay Kale Sir, Dr. Anita Dhole Madam, Dr. Sudhir Garar Sir, Dr. Karar Sir, Dr. K.N. Kadam Sir, Vocational Supervisor Praveen Utge Sir, and all others. And last but not least, all my dear participants, students, teachers, researchers. So thanks to you also. With this, I request to all of you, please fill the feedback link which is given in the chat box. So at last, I declare that today's session is over with the kind permission of Chief Organizer of the series. Thank you, Sonu Kumar sir. Thanks to all of you. Thank you very much, madam, for paying valuable time to us. Thank you very much.
Thank you, Prasarak sir.